Hi everyone, this is Pankaj Kumar Pandit, and again I am going to continue my DSA series. Actually, uh, maybe it's last year I started this, but I couldn't able to make it all those videos because I got placed in Cognizant. So after that, I just distracted myself and just joining later because this is my first time after getting placed. So I came to Bangalore and it's very new to me, Bangalore. So adjustment takes a lot of time. So now I am going to continue my series, and actually we have solved a lot of questions. Not lot of question. Actually, we completed this sliding window section, all the problems which required to be solved because these questions are very important. Don't solve any question before doing this all questions. So we did one question of 2 pointers as well. I will continue this 2 pointers, but today I am taking the question prefix sum. It's going to be the second question, that is product of array except itself. So it's open in here. So I just wanted to show you guys that how I am, like, let's say this is my profile things. Somebody is saying like, show me the profile of your lead code. Actually, I'm not great uh, problem solver because I'm just learning very slowly. So if you see, I am very consistent. Uh, if I'll make some decision, then I will continue. If you see my 2023, I started with 2023 with consistency. I maintain this for a year. If you able to see my screen, these are the green things. Like, I am a consistent for this year 2024. Then in 2025, I follow a half month consistency. Then I dropped totally because I came to Bengaluru and just trying to learn what the Bengaluru wants. So just let's jump into directly a question and read the question. Actually, it's a very simple question. You don't need to read all of those questions. Just read the question carefully. And the question says, okay, so I'll explain into directly a notepad. So let's jump into this thing. So what we have is that where it is. 1 second. Okay. So A, B, C, D, E, and F. Let's say this is the array elements we have, and let's do indexing 0, 1, 2, 3, 4, and 5. What we have to do, we have to calculate an answer. Let's say for index this, let's say this is index I, we have to calculate the answer. Product we have to calculate except this element. So what will be the product? The product is going to be A into B and D into E into F. So its left side, it's going to be L into A into B, and its right is going to be D into E into F. And if you multiply this both thing, L into R, you'll get A into B into D into E into F. So this is the answer for this index. Okay, we have to do the same thing for the all the index. So how we are going to do that is, it's a very simple, like let me erase this thing. It's not pay, not this one. Okay, let me take one more example how we will calculate for the index 3. So for this index, what is the answer is going to be? So let's say this is the index I, and for this its left side is this. So L equal to A into B into C, and R equal to E into F. So if you multiply this both thing, L into R, you'll get an answer for index 3. So it's going to be answer of 3, index 3. So L into R, what is L? A into B into C. And what is R? It's E into F. So whatever the answer it will give, it is for the index 3. So let me erase, not erase, just go down and okay, let me write it again. Okay, business. Okay. So A, B, C, D, E, and F for index 0, 1, 2, 3, 4, and 5. How you are going to apply the brute force approach? Like for every index, you will go. Let's say you are at index this. Okay, let's say this is I. Just initialize a 2 pointers. Like you have 2 sections. One is this is called L, and this is right. So what you will do, you'll just initialize, let's say green, 1 pointer here, let's say J equal to I minus 1, because if you see this is I minus 1, so this is I. For this we have to calculate the answer. So accepting this, we have to calculate. So we will initialize 1 pointer J. It will go one by one till the 0. So it is J equal to 1 right now. Then we will calculate the product for this J equal to 0 and until 0. So we will move right to left from here. And for this as well, we just initialize one more thing. Let's just take add 1. It's going to be K anything that is going to be I plus 1 and go till the end. I'll calculate the product, and after calculating L and R, just multiply this L into R to get the answer for this index. So this is the approach. If I'll write the code very quickly, so let me write it. Code for this. Okay, so let me use white one. So first we need to initialize and vector that is going to store the answer. Okay, now we will go initialize one loop, that is and I equal to 0, I is less than n, I plus plus. Okay, now int L is calculating the answer for the left side and R is calculating answer for the right side, and then int J is going to be I minus 1 and int K equal to K equal to plus 1. Okay, for left side, uh, while J is greater than or equal to 0, what we have to do, we just L equal to L into A of J and just decrement the J minus JJ. Okay, then we have to do the same thing for the right one, that is K is less than N. What we have to do, R equal to R into A of K and just increment 1. Okay, so after that you'll get the left and right, just push the multiplication of L and R. So answer dot push back L into R. So after this loop you'll get your answer. So this is the brute force approach. Like if you see for this L, it's a big O of n, and inside these two also taking big O of n, so it's going to be n into n. This is approximately big O of n square. So this is the brute force approach, how we are going to optimize this. And we also don't have to use the division. So let's just see A, B, C, D, E, and F. So if we do indexing 0, 1, 2, 3, 4, 5. So since this is the problem of prefix sum, you can try it on your own. Like, think about how we can apply the prefix sum over here. Since let's say I am taking one index, this one we have to calculate, and think about it how we are just utilizing, how we will utilize the prefix sum. Just for a 1 minute, pause the video and take your chance and see if you land the like right answer, then you are perfectly understand the prefix sum and like uh, this is the good intuition that you learned and you get the intuition. So those who not, or you just wanted to watch this, just be with me and just going ahead to solve this. Okay, so for index this one, like this one, we need its left and we need its right. Why we don't calculate, like पहले से हम calculate करके रखें, तो that means if we find like for this index, it's great to already have, like, let's say prefix, we called it prefix. So let's say a prefix of 2, it's contain a into b already, and the suffix of 2 contains d into e into f already. So if we know this thing left and right, we just have to multiply this. Okay, so we divided this problem into two things, like prefix and suffix. Suffix, don't worry about the suffix. I will tell you what is suffix. Suffix is going to be like not just abhi ke liye chodo. Let's just focus on the prefix. What is prefix? Prefix says that if you are calculating at index, any index I, okay, so let's say we are calculating any index I, so prefix of I says that I already calculated for you. Let's say prefix of 2, that means we are calculating answer for this 2. I already know the answer of like your right side, excluding yourself. So it's going to be A into B. It's not included C. So there is no C involved in that. Do you understand? Let's take one more example, then you will understand very easily. So A, B, C. Let's take another color. Pink one. Pinky. So A, B, C, D, E, and F. So 0, 1, 2, 3, 4, and 5. Okay. I want to calculate for this index. So let me take the green one. For this index, this is, let's say this is I now, and this is I equal to 1. Okay, I want answer for this. So prefix of I says that prefix of I, what is I? Prefix of 1, this is 1. What it says, except this element, except this index, I have the product of its right. So that means this is going to be A. Okay, let's take one more example. A, B, C, D, E, F, and its index is 0, 1, 2, 3, 4, and 5. So now this time I want answer for this. So this is going to be I, and I is going to be 4. So what prefix says? Prefix says that I have the product of prefix of I. In this case, prefix of I means prefix of 4. I already have the product of its right, except this element itself. So it is going to be this one, this all. Sorry. 1 second. Okay. This all, I have answers of prefix of 4. So A into B into C into D. Okay. So this is the prefix How we are going to calculate? It's very easy. So prefix is going to be like a, let me change the color again. I don't know what obsession with the color. So let's just change it. Let's just take a white one. A, B, C, D, E, and F. Mark the indexes 0, 1, 2, 3, 4, and 5. So how we are going to approach this? So let's say prefix of 0. Prefix of 0. What is prefix of 0? Except this. Except this. What is its left? Nothing. So you just put 1 here. Okay, let's just move to the prefix of 1. What prefix of 1 means? We have to calculate for the prefix of 1. That means except this element, what left side you have, it's only A. So just A. Okay, just erase it again. Now we are calculating for prefix of 2, and except this, what you have right side, sorry, left side, it's going to be A into B. Okay, and for same thing we will do for the all the indexes, and now it's easy for you as well, I think, because prefix of 3, except this thing, what you have, A into B into C. Now for prefix of 4, A into B into C into D. Except this thing, prefix of 4 will be this, and prefix of 5, A into B into C into D into E. Why not F? Because we are calculating prefix of that index, so we have to exclude this thing. So if you see, P of 0 is 1, P of 1 is A, and this is repeating thing. You can use this, let me take this. So this is already here, so we will just take it as a P of 1. Now for this is again repeating, let's say this P of 2, this is P of 3, and so on. This is how we will calculate the prefix. And if we calculate what is suffix, suffix is the same thing, but it's for the left side. So if I'll show you A, B, C, D, E, F, and the index 0, 1, 2, 3, 4, 5. So if I want to calculate for this index, what is the suffix of this index? I equal to 2. So suffix of 2, it's going to be, except this element, all the elements on the right side. This is right side. So what is the right side? D, E, and F. Why we are not including C? Because we have to exclude this thing. So for every index, let's just one second. A, B, C, D, E, and F. 0, 1, 2, 3, 4, and 5. We have to calculate this index I equal to 2. So we know that for every index we know prefix. So prefix is what? Prefix of 2. That means this multiplication we know, except this thing, this C, this is not included. And we know suffix of 2. Okay, so that is A into B, and for this into D into E into F. We know this thing. We know prefix of this thing, suffix of this thing, just multiplied, and you will get the answer for index 2. And we will do the same thing for the all the indices. Okay, so this is the thing, this is the approach we are going to use. And I'm just writing the code, not writing the sorry, I will just write code into the code editor directly, because it's just time wasting to write over here. So just I will explain over it here as well. So let's just write it. So let's just int n equal to nums dot size. Okay. Now we will initialize an answer. We need a prefix. So let's say prefix. You can call it prefix of size n and 1. Why 1 for 0? If you see for 0, there is no element. If you calculate this prefix, what is the prefix of 0? There is no element. So we are just putting 1 as it's going to be product. So we just have to put 1. Okay. And for suffix and of 1. So now we will calculate the prefix, calculate the suffix. Okay. So we will initialize j. I'm not j. Sorry. We will go int I equal to 1 2 and I plus plus. This is we are calculating prefix. Prefix of I is going to be prefix of I minus 1 and nums of I minus 1. Okay. And same thing we will do the suffix, but suffix is going to be reverse of this. And I equal to n minus 2. It will start from the right. It will go up to 0 I plus, sorry, I minus minus, and suffix of I is going to be suffix of I plus 1 and suffix of sorry, nums of I plus 1. Actually मैं ये क्वेश्चन पहले ही कर चुका हूँ. That's why I think my speed is increased just before. This is the second recording. I don't know, at that time screen recording fails to record the when I was explaining on the board. I hope this time it's recording. So that's why my speed is a little bit higher. I don't know. And then we will just initialize answer for int I equal to 0, I is less than n, I plus plus. And for every answer, I know, we know the prefix and the suffix, just we have to multiply it and push back. So it's going to be prefix of I into suffix of I. And this is our answer stored in this vector, and just return answer. So if I'll run this, it will pass the test case, initial test case. And if I'll submit this, it will be submitted without any error. So yeah, it is submitted, accepted. And for the time complexity, if you want to, let's say this is this taking big O of n, this is again big O of n, and for this is big O of n. So it's going to be big O of 3n, 3 times n. So 3 is the constant. So just big O of n, time complexity. And we have solved these things. In next upcoming video, we will solve this maximum product subarray. We have 3 left for the prefix sum, and then we will just move to the 2 pointers. Okay. See you in the next video. Thank you for watching.